But our angle, okay, x is not necessarily between the 0 and 2 pi. But any angle can be written in such form. So now let's look at the general case, case 3. And in this case, we let x equal to 2k pi plus y, with y between 0 and 2 pi, right? Any angle is coterminal with angle with the reading measure between the 0 and 2 pi, right? So now let's look at the sine x and the tangent half x. So in this case, sine x, and we know for sine, its period is equal to 2 pi, right? So when we just throw away this 2k pi, then first let's get the sine of the 2k pi plus y. Since 2 pi is period of sine function, so this is equal to sine y. And then let's talk about the tangent half x. So tangent half x, this is equal to tangent, okay, this guy divided by 2, you got k pi. And this guy divided by 2, you have the half y. And we know for the tangent function, the period is the pi, right? So we can throw away this k pi. Then we get tangent of y over 2. And now this y is between the 0 and the 2 pi. Then we may just use the results from the case 1 and case 2. We know for any angle between the 0 and the 2 pi, sine y and the tangent half y always have the same sign, right? So sine y and the tangent half y have the same sign, and so do sine x and tangent half x for any x. Then by now we finish the proof of this, okay, conjecture. That is the tangent half x and sine x have the same sign. Any question? Now let's come back to the identity for the tangent of half x. So half angle identity for tangent, and we just got the tangent of the half x equal to plus minus the x value of the sine over the 1 plus the cosine x. We know in this case 1 plus the cosine x is always positive, right? It cannot be equal to 0. It's bigger than 0. And tangent half x has the same sign as the sine x. So in this case, since this guy and this guy, they have the same abs value. Let's take the abs value of both sides. You have the abs value of tangent x equal to the abs value of the plus minus abs value of the sine x over the 1 plus the cosine x. And then let's just get rid of this plus minus sign. Then you get the abs value of the sine x over the 1 plus the cosine x. We just need one pair of the abs value bars here, right? We don't need to use the double abs values. So right now, this tangent half x has the same x value with this sine x over the 1 plus cosine x. And the sine of this part is determined by the sine of the sine x. And the sine of the sine x is same as the sine of the cotangent of half x. So if you have the two variables a and b, which have the same x values, and also a, b have the same sign, either they are both positive or they are both negative, then this just implies you have the a equal to b, right? For example, you have the negative 5 x value equal to the x value of the 5 minus 10. So now these two guys have the same x values and they also have the same sign. Then this just implies negative 5 is equal to 5 minus 10. Okay, so now these two guys, tangent half x and sine x over the 1 plus cosine x, they have the same x values. They have the same sign, okay, because the sine of this part is determined by the sine of the sine x. And sine x has the same sign as the tangent half x. So now, from this example, we know tangent half x is equal to sine x over the 1 plus cosine x. In this way, okay, in this way, we just geometrically simplify the half angle identity for the tangent. Any question? And here we can also derive another form for the half angle identity for the tangent. And let's move to the next page. So we know by now we have the tangent half x equal to sine x over the 1 plus the cosine x. And we can multiply both the numerator and denominator by 1 minus the cosine x. And then in the denominator, we have the 1 minus the cosine square x, right? A plus b times a minus b equal to a squared minus b squared. And in the denominator, we keep them in this factor form. So now, denominator, this is equal to sine square x. And then we cancel out one factor of the sine x. Then we get 1 minus cosine x over sine x. So this is another form of the half angle identity for tangent. Okay, all those half angle identities for sine, cosine, and tangent are summarized here. So for the sine half x, cosine half x, and tangent, okay, this is the original form, right? It depends on the sine before this radical sign. So, but if we use these two forms, we don't need to care about which sign to choose. But for this form, you have to use the position of the half x to determine the sign before this radical symbol.